So on this one, if you know your properties of sine, cosine graphs, you know that 31 is going to be your amplitude, and 43 is going to be your vertical shift. They just put it in the front instead of at the back end, you know. Typically, you know, we're looking y equals a times the sine of bx plus c plus d, right? And that d is your vertical shift at the end. Okay, they just threw that out in the front. Okay, so 31 is my amplitude, 43 is my vertical shift. So you don't need to graph this, but you can kind of visualize what it would look like a little bit. For your regular sine curve, you know that it goes up to 1, down to -1, up to 1, down to -1, right? Okay, where the x-axis is kind of like the level point. Well, what's that plus 43 do to that level point? Slides it way up 43 units, right? So wherever that is, all right? So here's kind of like my new level, right? And then 31 is my amplitude. So that tells me that my sine curve is going to, you know, end up going 31 above it, 31 below it, 31 above it, 31 below it, 31 above it, 31 below it, and so on, right? Okay. So I'm not even going to mess with what this actually looks like, but just kind of a rough idea in general, this is what the graph's going to look like. This represents temperature over time, and so since the middle is 43 and I go 31 above it, that tells me that the average hottest temperature is 74, 43 plus 31. And the average low temperature in a month is 43 minus 31, or 12. It also tells me then that 43 is the average of all the monthly average temperatures. So if you said the average temperature throughout the entire year in Minneapolis, you'd say 43. So I kind of know all those things now without even, you know, worrying about what the question's going to ask or things like that. Just because I have a rough idea of what this is going to look like. Yeah, I know there's probably some phase shift and blah, 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 blah. Okay. But just in general, that's what I already know simply by looking at the equation. I know where my middle would be, I know where my high would be, I know where my low would be. Feel like you could make that conclusion if you saw an equation like this?
Yep.
Okay. All right, now what does the question even ask? I don't even remember.
What is the difference between the average monthly temperatures for July and January? And then what is the relationship between this difference and the coefficient of the sine term?
Okay, so if you want to find the average monthly temperature in January, all you got to do is plug in a 1 for T, because T is time in months. If you wanted to find the average monthly temperature in March, you'd plug in a 3. July, plug in a 7. December, plug in a 12, you know. Just whatever month it is, you plug that number in for T. Make sure your calculator's in radian mode when you do that to get your answer, because this is sine of a radian angle here, okay, or radian measure. But so anyway, that's to find the average monthly temperature in January, plug in a 1, see what you get. To find the average monthly temperature in July, plug in a 7, see what you get. Okay, I do remember, well, January is the coldest month, July is the warmest month. So I think July was when we got an answer of 74, and January we got an answer of 12. So the difference between those, 74 minus 12, would be 62. Not surprising, 62 is double the amplitude, because it makes sense. If we're going 31 above the mean and 31 below, how far apart are the high and the low? 62. Okay, that should make sense. What else does it ask?
What's the relationship between this difference and the coefficient of the sine term? So
that's what we just talked about. Yep. What's the relationship between the coefficient of the sine term? So what's the relationship between 31 and the difference between the high and the low? Obviously, the difference between the high and the low would be double whatever that amplitude is. What's next?
What is the sum of the average monthly temperature for July and January?
So if we add the July temp with the January temp, 74 plus 12 is 86. Okay?
And then what is the relationship between this sum and the value of the constant term?
So how does 86 compare to this?
It's double.
Double that again, which makes sense. If 43 is the average, if we add our high and we add our low together, it should equal twice that, because If I were to add the high and the low together and divide by 2 to find the average, I should get 43. So when you add two temperatures together, it should equal double that.
Okay.
So that's kind of what they're just wanting you to start drawing some conclusions by simply looking at an equation. You could draw the graph, you could enter that onto Desmos, and it'll draw it for you, all right, but you really don't need to. I think you can answer all the questions just by simply thinking about what each one of these values here, how that impacts what the graph would look like.
Gotcha.
Okay on that one?